Okay, this is just going to be a quick review of how to set up typical story problems that you might see. So the first one we're going to do is work problems. That's when there's somebody that does a task and there's somebody else that does a task. And if they're working together, how much time does it take the two of them to complete the task, right? So working together means plus sign. So essentially this is the setup. Work plus work equals total work. Or you might be missing. We don't know how much it takes for this person to do the work, but together we know this much. So it'll be this person plus the missing variable equal, and then you need to solve. So let's go ahead and look at a couple of these. So notice, working alone, it takes Emily 15 hours to pick 40 bushels of apples. Remember, picking 40 bushels of apples, that's just a distractor. A 40 bushel container might look something like this. So this 40 bushel container is just the one task. Ryan can pick. So here's one. They give us the two. Emily, we know how long it takes Emily, and we know how long it takes Ryan. So this would be the setup. Emily, so one task in a certain number of hours, and that same task in a certain number of hours. We'll call that A, we'll call that B. We need to find out how long it takes them to do that one task. Again, assuming they kept at the same constant rate. How long did it take? All right, so that's the basic setup. And then this is like 6th grade fraction stuff, right? Find the common denominator, then solve for x. So now when they tell us, the other setup is when working together, Dan and Natalie can tar roof. They tell us how long it takes them to do it together. We don't know one of their times. Let's see, had she done it alone, Natalie, it would have taken Natalie 8 hours, and we don't know. Find out how long it would have taken Dan. So guess what? Get this by itself. So subtract the 1/8 both sides, and then find common denominators and solve like you normally would. All right, let's go ahead and go on to the other. So you've got distance problems, and there really is 2, sometimes 3 setups. There's the first one where somebody is starting someplace, they're going to another place, then they return. So it's there and back. And notice these 2 distances equal each other. So you're just going to set those 2 equations equal to each other and solve. The other situation is where we have 2 different things, say 2 airplanes going in opposite directions. So this is going to be a rate times time, and this is going to be a rate times time. Well, those 2 things added together equal the total distance. Typically, you're going to know the distance. You're going to have to solve for one of the other things. Okay, so let's go ahead and take a look at that. Whoops. So a cargo plane left Singapore three hours before an Air Force plane. The planes flew in opposite directions. So notice we have that right here. We have the cargo plane flying in one direction and the Air Force plane flying in the opposite direction. So the cargo's rate times time plus the Air Force's rate times time is going to equal the total distance. And notice they give us the total distance. So let me go ahead and see if I can move all that and erase what I just did. Yeah, so there would be the diagram right there, and then you would fill in those other pieces. And this one, Norakai made a trip to the lake and back, so that's a there and return. So it looks something like that. All right, so that's the basic setup. Once in a while, you're going to have a situation where 2 people are going the same direction, but one of them leaves later and then they catch up. Well, these 2 distances also equal each other. All right, the final type of problem is mixture problems. And here's kind of a better diagram than I was doing last week. So here's the basic setup. When you say are a chemist or you work in the, I don't know, soils industry or something, and you have to mix concentrations. So the percents that you see are the concentrations of things, whether it's mixed nuts or whether it's concentration of soils, or in this case, sugar solution. The percent is always the concentration of things. So the easy setup was if they give you an amount and they tell you the concentration, they give you another amount, they tell you the concentration. Well, these two amounts can be added together to get the total amount, and then you just solve. So it's the amount times the concentration in decimals plus the amount times the concentration in decimals is equal the two amounts added together. And we don't know what the new concentration is. So this is just basic math. The very last step, you're going to divide the sum of those two things. You're going to divide those two things together. Another setup would be, so let me cover this up, is when maybe one of the amounts or maybe one of the concentrations is missing and you have to solve for it. So notice this X amount is missing. So when the total amount gets added together, it's still amount plus amount. And then you're going to have to get the X's once you simplify. So X times this percent plus amount times this percent. Oops, this percent. Now this is going to be a distributive. So you're going to have X times a percent plus this amount times this percent, that concentration. And then look at, you're going to get the X's to one side and then the amounts to the other, and then you would solve. All right, that's it for the basic setup on how you do these problems.